Hello Internet, welcome to another microprocessor tutorial. In this tutorial we are going to touch upon the topic of interrupts of 8085. The interrupt structure of 8085 is very important to learn if you want to be proficient in programming 8085 with peripherals. If you are aware of the pinout diagram of 8085, then you must be aware of the names of the hardware interrupts, which are in the form of pins on the IC of 8085. So when we start the study of interrupts of 8085, we divide the interrupts into two parts. One is the hardware interrupts, and second would of course be the software interrupts. They are in the form of instructions and they are in the form of pins on IC. Now there are 5 hardware interrupts in 8085, namely trap, RST 5.5, RST 6.5, RST 7.5 and INTR. And there are 8 software interrupts in 8085. All of them are instructions by the name of RST, and they start from 0 and go up to 7. Now we are aware of the fact that any signal on these pins on IC would immediately cause the microprocessor to pause its functioning and serve what is being requested on these pins. And similarly, a software interrupt within a program would halt the program at that particular location and will take the microprocessor to an address to which this software interrupt is pointing. So the most important concept while we study interrupts is the vector addresses of the interrupts. Now what happens is, whenever an interrupt is occurred, that interrupt takes the microprocessor to a specific location in the memory. So the program is paused or halted at the location where the interrupt is placed, and it then subroutines the microprocessor into another location, which is of course the interrupt location. And each of these interrupts have a specified address to which microprocessor points after it encounters these interrupts. And that is why, because each of these each of these interrupts have a specific vector address, so these interrupts are known as vector interrupts except for this one. This is a non-vectored interrupt, but rest all of them are vectored interrupts. And how do you calculate the vector addresses of these interrupts? This is pretty simple. This is a trick that you can follow to calculate the vector addresses instead of learning them. Now vector addresses are calculated by the number which is specified along with the RST multiplied by 0008H. So if you were to calculate the vector address of RST 0, that will be the starting location of the memory, and similarly this will be 8 registers away. 1 into 0008H would bring us here, and similarly they are 8 locations apart from each other. And if you were to calculate the vector addresses of RST 5.5, then you could do this trick, and that will give us the vector address for RST 5.5. Now what I'll do is I'll write down the vector addresses of all these interrupts here, and I'll show you how you can calculate the vector addresses of a numeral which has a decimal point. And trap is, by the way, another name for trap is RST 4.5. Alright, so the vector address for RST2 would be 8 locations away from this hexadecimal address. That will be 0010H, and then 3 would be 0018H, then this will be 0020H, 0028H, 0030H, and 0038H. Now calculating this is pretty simple, and now if you were to calculate the address of RST 4.5 or the vector address of trap, that would lie in the middle of 4 and 5. So what you could do is you could start counting from 2 0, then you go to 2 1, 2 2, 2 3, 2 0, 2 1, 2 2, and 2 3, and it starts from 2 4. So you could write down the vector address for RST 4.5 to be 0024H, and similarly 5.5 will lie between 5 and 6, so that will be 28, 29, 2A, 2B left out, and it will be 2C. So 002C, and then 6.5 will lie between 30 and 38, exactly in the middle, so that will be 0034, and finally 003CH. So these vector addresses are super important to understand, and very, very important, because microprocessor will be taken to these vector addresses once these interrupts are encountered. And alright, now we'll talk about the priorities of the interrupts. Let's talk about the priorities of hardware interrupts first. Trap has the highest priority. That means it is a non-maskable interrupt. No other interrupt can stop the functioning of trap. On the other hand, if some lower priority interrupt is being serviced by microprocessor, for example RST 5.5, and on top of that RST 7.5 comes, so microprocessor will subroutine itself to the vector address of 7.5, ignoring 5.5. Not ignoring exactly, it will pause the functioning of RST 5.5 momentarily and will service 7.5 and come back to 5.5 once the servicing of 7.5 is done. So it is important to understand and know the priorities of these interrupts. I'll write down the order of the priority starting from the highest priority. Trap has the highest priority, followed by RST 7.5, RST 6.5 and RST 5.5. And when we talk about the software interrupts, RST 7 has the highest priority, and the priority decreases as the number followed by RST decreases. And to enable and disable these interrupts, we can use two different commands, EI and DI. EI is enable interrupts. Now this is going to enable all the interrupts. Microprocessor will be welcoming to all the interrupts. If you start your program by writing DI followed by the codes of the process that you want to execute, then the process will not be interrupted by any of the interrupts except for trap. You cannot stop trap. So disable interrupt is one way of keeping the interrupts away when you wish to do uninterrupted programming, but then again trap is an exception. Now INTR is one such interrupt that has the lowest priority. It is a non-vectored interrupt. If any signal for interrupt is encountered on the INTR pin, it should be followed, or it should have its own vector address. INTR requires the peripheral device to provide the vector address to where microprocessor will be branched. So INTR is absolutely the lowest priority interrupt, non-vectored interrupt. Very important point to remember for MCQs and from the interview point of view. But that is all for the introduction of interrupts. I'll talk about the set interrupt mask and read interrupt mask instructions, where we can disable or enable the interrupts individually. We can change the priorities and so on and so forth, having more control over the interrupt structure using sim and rim commands. So I'll talk about that in another lecture, but that's about it for today's lecture. Super introductory but super important. So thank you so much for watching the video. Once again, thank you for stopping by and giving support to the channel. If you liked the content of this video, please give it a thumbs up and consider subscribing. Have a good day, good life. Bye.